So let us understand how to deploy Amazon EKS cluster in auto mode and also explore various functionalities. For example, the compute cluster capabilities, the network capabilities, storage capabilities, and also troubleshooting. Okay. Now let's first proceed with the cluster creation. So let us first create Amazon VPC and EKS cluster in the auto mode. Okay, so let's go to this folder and do Terraform init, plan and apply. Okay, now let's go to the source code and see how the code looks like. So I'm inside this folder and this is my main.tf. So let me run Terraform init and I'll run Terraform plan. Okay, so Terraform plan completed. As you see, there are so many resources it needs to add. 0 to change, 0 to destroy. Okay, so a lot of resources. We'll explore the configuration for most of these resources in a minute, but I'll go ahead and run Terraform apply with auto approve. Okay, so while this will take some time, we'll explain how the configuration looks like. Let us first start with main.tf. So this is my provider. I'm assuming a different AWS profile in a different account. Okay, and this is where my provider for the Kubernetes and provider for the Helm and the kubelet configuration. Okay, so I'm using the module.eks.cluster endpoint. So this is a module that we're creating it, and this is a certification, and this is a token. So this is the module that I've created. It is based on Amazon EKS Terraform blueprints. So this is the name of the module, EKS blueprints, EKS auto mode version 0.1. Okay. So some of the parameters I'm passing is the region, the VPC name, CIDR, and attach secondary CIDR blocks, and the secondary CIDR blocks itself, number of AZs to consider, private subnet, public subnet, database subnets. Okay, cluster name, cluster version, and enable cert manager. This is true by default. So if I go to my terraform.tf vars file, so you will see this is the configuration. So name of the cluster is EKS auto mode. So both the VPC name and the cluster mode is same, and this is a version 1.30, which is n-1, and 3 AZs I wanted to create. I want to use 3 AZs to create the subnets, and this is my CIDR block. Okay, we will discuss why I have chosen this CIDR block in the networking section. So primarily, I'm using this subnet for the data plane. So it has /24, which is 256 times 3, 784 IPs for the worker nodes and the pods. Okay, and public subnet is /27, which is 64 times 3, right? So sorry, it is 32, right? /27 is 32 times 3, which is 96 IPs. Similarly, for the database, it will be /27, which is 32 times 3. 96 IPs are more than enough for public subnets and the database subnets, because in the public subnet, we hardly create any load balancers, maybe a couple of load balancers. Each load balancer will take only 3 IPs, one from each AZ. Okay, and similarly, the database, if you are using the managed database like RDS, Postgres, they will create ENIs in the subnets. So they will take just one IP from each subnet. So we don't need to create a bigger CIDR block for the database and the public subnets. I've seen again and again that customers will allocate a larger block of IPs for the public and the database, though we don't use it. Okay. Okay. So these are the set of subnets I'm passing, and I'm also attaching the secondary CIDR block. So these are the set of private subnets, and I'm also attaching a secondary CIDR block, true, and this is the CIDR block size, and these are the 3 private subnets that I'm using for the additional CIDRs, because the primary CIDR that we have is too small, because it has only 700 around 784 IPs for the worker nodes and the pods. So I'm using this set of additional CIDRs for the worker nodes and the pods later, because these IPs are coming from RFC 1918 series. Typically, organizations will not have too many IPs here because they'll be using the same IP space for across the applications in the on-prem and also in other clouds. Okay, so this is where I'm using a additional sided block, and this is my name of the cluster. This is a version, and cert manager also I'm enabling it to true. Okay, now this is the configuration. Now let me go to the module that we have created. This is the EKS auto mode version 1. This is the main eks.tf file. So you see a module for EKS. So I'm using this Terraform version 20.31 for the EKS module. I'm providing the cluster name, cluster version, IRAC true, and the public and private endpoint is true. Authentication mode is API and config map. And I want to provide admin privileges to the IAM identity which is creating the cluster. And this is important block. Okay, this is where I'm enabling the EKS auto mode. So enable is equal to true. In the node pools, I'm creating general purpose and system. And this is the role I'm creating it. Okay, so this is a VPC ID and the subnets. These are the private subnets, and some security group defaults I'm creating it. The ingress I just want to avoid, allow the ports from 10252 to 65,000, and similarly for the egress rules I want to allow all traffic. KMS key for the envelope encryption I am enabling it, and I'm also providing some extra identity for the trust policy. Okay, so these are the aliases. Now coming to the role, so this is the policy document for the Amazon EKS auto mode role, and this is the name of the role, and these are the managed policies. Okay, that's it. It's very simple. Now if I go to EKS add-on.tf file, so here you see I'm using EKS blueprints. Okay, so this version and a few parameters required for the cluster, and so I'm not using the bridge mode here. Okay, I wanted to create the entire modules using Terraform only for now. So in the EKS add-ons, I'm not defining VPC CNI, proxy, core DNS. Previously we used to define that, but here I'm not defining that because those are the cluster capabilities. Okay, so but apart from that, I'm also installing a CSI driver for S3. Okay, this is part of the blueprints add-on. Similarly, EFS driver I'm creating it, and snapshot controller also I'm installing it. So one thing to note is I have selected the node pool, which is the system node pool. So out of the two node pools, what is a system, what is a general purpose? The system node pool is typically used for all the core critical add-ons, daemon sets that the cluster-wide applications require. Okay, so I wanted to deploy these add-ons into this specific node pool. So that's why I'm using the node pool node selector with this particular label. Okay, so we can do that for other add-ons also, but I just selected it for snapshot controller to show this how it works. Okay, similarly cert manager I'm enabling it, and there are some values coming for that, and here also I am providing the name of the node pool and the the label key and the value. Okay, so if you look at the cert manager dot values Helm chart, so if you see, for example, let me search for the node selector, or let me search with this particular variable that I'm defining it. For example, this is the node label key. Okay, so if I go here, so I'm defining these two variables, node label key and value, so as a part of the node selector, and providing the values. So the values are, this is a carpenter node pool and the system is the value. Similarly, I'm enabling CloudWatch metric. Okay, here I'm not selecting any node pool. So I'm also deploying the AWS Fluent Beat add-on. Okay, so CSI driver is also deployed to the cluster. VPM enabling it, and that's it. Okay, so if you see, the EKS add-on section is quite simple because we are not adding many add-ons here, because most of the add-ons are by default available. And also I'm creating a storage class. Okay, I wanted to make GP3 as a default, so I'm making GP2 as false, is default false. And I'm creating a storage class for GP3, and we need to keep in mind the storage provision name is changing now. In Amazon EKS, this is the name ebase.csi.aws.com, but for Amazon EKS mode, ebase.csi.eks.amazonaws.com. So this is important to keep in mind. So I'm using this particular name, okay, and some of the parameters that you can mention here for the ebase values. So I'm creating a S3 bucket for the fluent bit, okay, IRSA role for the S3 CSA driver, one point driver, and few more IAM policies for that. So these are the IAM permissions and the roles, okay. So this is very simple configuration. So two files, eks.tf and eksaddon.tf. So now the cluster is getting created. Now let's go to the console and see how this looks like, okay. I'll pause the video for some time. Another few minutes, the entire infrastructure will be in place. Then we'll access the cluster. The Terraform apply completed. As you see, we have the output. So this is the control plane API server endpoint, the name of the cluster, and this is the kubeconfig command line to create for this cluster. And these are the subnets and their cider sizes. Okay. Now let us go ahead and create the kube context for this cluster. So let us first see in the console how this looks like. Okay, so this is the EKS auto mode cluster. Version is 1.30 and auto mode is enabled. So if you see, auto mode is enabled here, and upgrade policies by default extended. In this case I'm using the Terraform, so I've not made it to standard, and secret encryption is enabled, so envelope encryption is created. In the resources I don't see it because see here because I have my IAM role not whitelisted in the RBAC. So that means I need to add my IAM role to the cluster RBAC to be able to see all the objects that we will see in a minute and how to do that. So on the compute side, if you see, there are two built-in node pools, general purpose in the system. Okay, there are no node groups, so we don't have to create any many node groups nor the forget profiles. Networking side, this is my VPC. So let us go there. So I have two CIDRs, 10.0.0.0/22, 1000 IPs, 100.64.0.0/16, which is 65,000 IPs. Okay. Now, if I go to the subnets and filter with this particular VPC ID, you see there are different subnets. One is a public subnet of size 27. So there are 27 IPs. So 32 IPs because 5 IPs are reserved by VPC. So 32 minus 5, 27 times 3. Okay. And then we have private IPs. This is a secondary subnet IPs. So we are creating a larger CIDRs /18, which is 16,000 IPs. Similarly, the data plane, which is /24, which is 256 times 3, almost 750 IPs here. Similarly, for the database subnet also, we are using the /27, which is 32 IPs basically, right? So these are the subnets that I'm using for the VPC, and I'm using this subnet as a part of the cluster creation. So if you look at the subnets which I'm using for the cluster creation, these are the private DP1. Okay, so if you look at the private DP1, so these are the three subnets. Okay, DP1, 1A, 1B, 1C. Okay, and then on add-ons, I'm installing CSI driver, EFS CSI driver, snapshot controller. These are not core capabilities. Okay, the core capabilities are VPC CNI, Q proxy, core DNS, so pod identity. So those are not listed here because they are built as a system D process on every node. Okay, so these are my access entries. So this is my, for example, the EKS cluster created. This is IAM role. using which I am creating this cluster, and this is the worker node role. Okay, this is auto role, and this is the another role that I'm using. Okay, for the capabilities. This is the service role that we discussed earlier, which contains all the capabilities for the cluster operations. Okay, then I have a pod identity also attached for the fluent bit. I'm using the pod identity association with the fluent bit adder. So observability, I have not added any managed scrapers here. Control plane logging also I have not enabled. Okay, and this is by default. Now let me go ahead and add an access entry for my user. So I logged in as user underscore admin into this console. So let me add that. So let me create a access entry, and the user that I'm going to use is the user underscore admin, and the type is standard. Here I will use a policy. Okay, the cluster admin policy. I will add this policy. Okay, then go next and create it. So now this policy is added, so I can go back and just check the access entries. So let me just refresh this. That error is now gone, so I can see the user admin is given admin access. Okay, now if I go back to the resources and see, there are so many pods created automatically, and there are some nodes also created. Let us see why these nodes are created, because we have not deployed any workload in the cluster so far, right? We just created a cluster with some default add-ons and few additional add-ons. So if you look at the compute, this is the auto mode, so which indicates that these nodes are managed by the EKS auto mode service. Okay, and it is created by this particular node pool. So you can see the system node pool, the general purpose node pool. Okay, so I'll just open this in a separate tab, and this is the configuration which is by default provided, and this is the set of events on this. So you can also, for the debugging purpose, you can see the events here. You can also look at the kubectl get events also in the cluster to get all the status updates on the node life cycle. Okay, so these are the nodes. We will see why these are created, and from the pod side, most of them are the daemon pods. So if you see, there's the metric server, set manager, CSI driver for the EFS and EBS and things like that. Okay, so let us log into the console. So before we log in, let us first create a kube context. So this is the command. So I'm using this profile because the cluster is created in different account, and this is the command to create the kube context. This is the name of the cluster. I'm creating some aliases, and this is the role. Okay, this is the target account and this is the role. So I'll just copy this command. So I can just check now, get nodes, and I can also check get pods across all the namespaces. So these are the pods created, okay, within the cluster. Most of these pods are basically the add-on pods. Okay, I don't have any workloads created. So if you look at the namespaces, you will see the set manager, the kube system default, the no pods in the default namespace. So we will deploy some pods and see how the node pools will create the nodes for these pods. So let me see the default node pools in the cluster. Okay, so there are two node pools, general purpose and system. So there are two nodes created out of general purpose node pool and one node created out of system. So if you look at the Terraform scripts, we created the CSI snapshot driver, and we provided the node selector as a system node pool. Okay, so that's why one node is created, and the remaining add-ons we didn't provide any node selector, so that's why the general purpose node pool is created. Okay, so if you look at the node class also in the cluster, so we have one default node class. Okay, so if you wanted to see the configuration for the node pool, just to get an idea, so let me check for general purpose. So you will see the specification including the disruption budget, consolidation after 30 seconds, empty or underutilized, and various options to select the instances, expiry after 330 hours, 336 hours, which is 15 days, and termination grace period of 24 hours. Similarly, if you want to check for the system also, it is similar configuration except that it will have some taints configured. Like, for example, this is the taints that we saw earlier. Okay. And similarly, if you wanted to check the configuration for the node class, so the node class default will have this specification. So it has the ephemeral storage, networking policy default allow, network policy events log is disabled, and this is a node IAM role. Security group is pre-built. SNAT policy is random. There are two options: disable the random, by default it is random. Okay, so we will discuss that later. And security subnet are what we provided as a part of the cluster creation, right? So these are the node class. So, and if you look at all the parts once again, you will see that. So just to double check what all the things created. So this is the class group. We'll see that later. So set manager, CSI driver, metric server, and S3 mount point, secret CSI store, snapshot controller, VP admission controller. So these are the things that we have configured as a part of the Terraform. Okay.